So right here you have an isosceles triangle. The two congruent sides, those are called the legs. The angle at what you see at the top, right here, this angle is called the vertex angle. Because it's at the vertex of the triangle. So that angle that's like between the two legs. And then the base is the third side, so the side that's not congruent, we call that the base. And then the two angles that are right next to the base and in between the legs of the triangles too, those are called the base angles, and those are adjacent to the base. So these two here. Base angles theorem. So the theorem we talked about last week was that the three interior angles of a triangle have to add to 180. That's the main one we talked about. Here's another one for you, and we'll add this to your gold sheet after break. If two sides of a triangle are congruent, then the angles opposite them are congruent. So since these, if you have this first, if you know that those two sides are congruent, then you can say that the base angles are congruent. That is your conclusion. You will use this quite a bit when we get to proving things when you come back from break. And so if you use the converse of that, it would just be flip that statement around. If the base angles are congruent, then you have two congruent sides. So the converse says if you have the angles congruent, then you have the sides congruent. So AB would be congruent to AC. A couple things that follow from that. If you have, so that's what corollary means, is something that like follows a theorem. So because those theorems are true, if a triangle is equilateral, it's equiangular. So if the sides are congruent, the angles are also congruent. And then if you know that the angles are congruent, so if it's equiangular, then it's got to be equilateral. Okay, we're going to just do some examples with these and be done. All right. In triangle DEF, DE is congruent to DF. So we're looking at this very top one. Name two congruent angles. So over here, can you please name two congruent angles you can discuss with your partner? What are the two congruent angles if you know that DE is congruent to DF? Alex, what would the two congruent angles be?
Angle E and angle F.
Right. The base angles. So these two right here must be congruent. Okay, next problem. If HJ is congruent, I said HJ. If HG is congruent to HK, let's mark that first. So HG and HK are right here. Then which two angles are congruent? And when you're naming these, you can't just use one letter because K is part of two angles. So you have to use that three-letter naming system. So can you please write down what are the two congruent angles, or you can talk about it with your partner. What are the two congruent angles here? Your base angles. Megan, what would they be?
HGK and HKG.
Right. These two. HJK and HKG. All right. And that is using, that's still just a regular base angles theorem. Now we're going to use the converse. So if you have that these two angles are congruent, KHJ, that would be here. I'm marking it in the corner. And KJH, that's the other little one. So I'll zoom in. Which two sides then are congruent? Brooke, which two sides are congruent then?
HK and KJ.
Right. These two sides, HK and KJ. Because you have congruent angles, you can say that, well, that's an isosceles triangle, and so those two sides KH and KJ are congruent. And remember, when we're using congruent, we do go ahead and put the labels on top to mark it as a segment. You don't do that if it's an equal sign, but it's not. Okay, now we're going to start finding some measures. So example 1 here, find the measure of each angle. You know that all the sides are congruent, so what kind of triangle is that? Equilateral. And if it's equilateral, what else is it? It's equiangular. So it's equilateral. So it also must be equiangular. So we can mark that all the angles are congruent. All the angles have to be the same, so what's the only possible thing that they could be? Let's think about it. Okay, what do those angles add up to? 180. And they all have to be the same, so we could just divide by 3. What's 180 divided by 3? 60. So all the angles must be equal to 60 degrees because they all have to be the same. Is it possible for an equilateral triangle to have an angle measure other than 60 degrees? Tori, you're saying no. Why not? Right. So they all have to be the same. The only way to do that is if they're all 60. So 60 plus 60 plus 60 equals 180. And that is the only number that works for. Now in the next one, this guy is marked as equiangular because hopefully you notice that all the angles are congruent. So what would ST have to be? So again, we know it's equiangular. Let's backtrack. If it's equiangular, then what else is it? Equilateral. And so since it's equilateral, all the sides have to be the same. Guys, what is ST? 5. Because all the sides have to be 5. Okay, on the last two, I'm going to let you try it and see if you can figure out all the missing pieces, please. So figure out X and Y. Now we need to find the values of X and Y. Okay, we should notice that this triangle up here is equiangular. And so if this side over here, KL, is 4, then Y also has to be 4. And so does LN. Okay, moving on to the other triangle, we know that these two base angles are congruent. So we're going to use the converse of base angles theorem to say that, well, these two sides then must be congruent. So 4 equals X plus 1. Well, if we subtract 1, we know that X has to be 3. So X equals 3 and Y equals 4. On the last one, we're dealing with angle measures. First thing you should notice is that we have an equilateral triangle. Well, since that's equilateral, it's also equiangular. We know that all the angles in the equilateral triangle have to be 60, because 60 plus 60 plus 60 equals 180. So we know x is 60. Okay. If you look down here, you should see that there's a right angle. And so that means that they have to add up to 90. These two are complementary. So the angle right beside 60 should be 30, meaning, and since we have an isosceles triangle, it's marked congruent. We know that the base angles are congruent, so this one's also 30. Well, that gives me 60 if I add up those two, and so I have 120 remaining. So y is 120.